all right? Because each step give you 1 mark, all right? Normally, in fact, in energy balance calculation or energy balance question, for certain, how do I say that? For certain questions, in fact, the steps or the path that you create give you 1 mark. Okay, so that's why you have to show it correctly lah, right? Now the second one, the definition, we just omit the definition because this one is on reactive, this one. But before that, any question for this one? Any question?
No, madam.
No. So Najmi and Azhar dapat ke?
Dapat.
Okay. So next question. So if you refer to the B question do you think we have any calculation to be made?
No.
No calculation. Betul, no calculation at all. Okay, because if it is if there is any calculation required, then they may ask us about calculate or determine. Okay, so this one is correct, C1, C2, because no calculation. Calculation, you can go up to C4, C3. So no C4, C3, so it's actually a definition, okay, explanation, elaboration. Okay, so for this one, you are required to draw the hypothetical process path of the inlet and outlet streams. And then use the hypothetical process path to express the energy balance equation of the system. Okay, so you have liquid water 50 degrees C, 1 bar, heated and vaporized to 400 degrees C and 3 bar. Okay, so for inlet, now you are given the reference state. You are given the reference state. So you have to refer to the reference state. Okay, basically kita akan move from initial, if I can draw, liquid 50 degrees C, vapor 400 degrees C. Basically, kita akan move from initial, this is initial to final. Okay, so basically we will draw the hypothetical path to from initial to final. So initial will be our reference state. Okay, but for this question, you already given the reference state. Basically, why the reference state is given, normally we as lecturer bila kita marking, kita nak ada a standard answer of that. If we give you no reference, then you all boleh create berapa reference? I guess 3 reference. So 3 reference, if you do 3 reference, then this is still okay lah because doesn't involve any calculation. If it involve calculation, then we have multiples of answer. Okay, for only 10 students, then okay. For 400 students, so very tiring lah, okay, because we can get a same pattern of answering. Okay, so for this one, inlet, how many path are you getting? Inlet untuk water, berapa path? Anybody? Draw hypothetical process path of the inlet streams. How many paths do you get? Huh? 5 inlet. Kasha dapat 5.
6.
Najmi dapat berapa? 3.
6.
6. Kasha, you dapat 5 tu, what is your first path? Okay, liquid water 25 degrees C and 1 bar. Okay. Liquid 50 degrees C, 1 bar. Lepas tu, after that? Okay, so If you refer to the question, dia nak inlet and outlet. You should split lah the inlet and outlet. You cannot go from inlet to outlet direct from the reference state inlet and then go to outlet. Cannot. So it's only one step. One. You stop until liquid 50 degree C 1 bar. That's for inlet. So you should mention somewhere in the solution, inlet. Inlet, water, liquid 25 degree C, 1 atm or 1 bar. To water, liquid 50 degree C, 1 bar. You stop there because this is the condition of the inlet. So no 5, no 6, it's only 1. Okay, Najmi, 1
Okay, madam.
Alright. So for outlet?
4.
Outlet 4 No. Siapa yang jawab 4 tadi
Saya
Faiz. Okay, dia start pada mana Faiz?
start akan dia
Reference state.
naikkan temperature ke?
No, the
Lepas
first kali daripada reference state kan?
Reference state.
Reference state. Increase,
Naikkan.
lepas tu first step buat apa? Increase temperature.
Increase temperature.
Betul.
Lepas tu phase.
Okay.
Lepas tu temperature.
Okay.
Lepas tu pressure.
Betul. So 4 steps for the outlet. So you kena mention lah here outlet. You start from the reference state, liquid 25 degree C, 1 bar. So you have 4 steps tadi tu. 4 lah. Okay. So you have to split the inlet and the outlet punya hypothetical path. You cannot combine the two together because you have two different, you have specific reference state. If the reference state is not given, if the reference state this liquid water 25 degree C1 bar is not given, you can use this as a reference state macam saya cakap tadi. So if you use this reference state, you buat H2O untuk inlet, what will be kalau you pilih this as your reference state for inlet, no path. Because reference state is the condition of the initial. For final or for outlet, the reference state will be liquid 50 degree C, 1 bar. You start from the inlet punya condition because you pilih dia sebagai reference state. You increase to 100 degree C, the first step. The second step, you change the phase. Okay, change the phase. The third step, the second step, the third step, kamu increase to 400 degree C, and the last step increase the pressure. So there will be the same path as using 25 degree C ni as the reference state. So sama je sebenarnya. But this one, as I mentioned, the reference state is already given. So untuk inlet you have 1, untuk outlet you have 4. Okay. So alright, so how are you going to explain about this? Use the hypothetical process path to express the energy balance equation of the system. How are you going to solve this?
Combine both.
Combine both. Combine both is still about hypothetical process path. It's nothing to do with the energy balance. Although path tu adalah within the energy balance lah. Tapi macam mana kita kata, the topic is under hypothetical process path. You combine both. So for this one, I have no exact answer scheme for this. So, but I guess the energy balance, the hypothetical process path to express the energy balance equation, you should give short explanation lah. I think you should give a short explanation. For example, this one. This is what? temperature change. So you mentioned here, this is temperature change. Temperature change. To make it better from 25 degrees C to 50 degrees C. Okay, so what is the enthalpy here? I think the enthalpy is means by that energy balance equation. So the enthalpy is what? CP/dT. CP water liquid. If you want to add 25 to 50 lagi bagus. I think that is the meaning of that. Use the particle process path to express the energy balance. Okay. So you mentioned about the step actually involve temperature change and the enthalpy is CP/dT. So I think the enthalpy ni yang dimaksudkan dengan energy balance ni. Okay. If you refer to the next question ni, yang ni next question ni, refer to this is 16 marks. So kalau 16 marks, I guess the answer should be, the elaboration tu should be more lah. Okay, so for this one you just mention about temperature change and then you kata delta H-nya adalah CP/dT. So I think that's good enough. CP tu CP for water liquid because here dekat outlet you have CP for water vapor. Okay, so if you just put CP/dT, then I will ask what the CP actually refer to what. Macam tu pula. So you better put, because energy balance kan, the phase is quite critical. So you put CP for what? For water liquid, for water vapor, whatever lah. Alright. So for this one, the outlet ni, same goes to the outlet lah. The explanationnya, the first step you kata temperature change. So you kata temperature change, the enthalpy is what? Is CP/dT. CP/dT of water, water liquid. For second step, phase change. So phase change, you mentioned phase change, and then the second one, dia tanya apa kalau phase change? Kalau phase change? Where can you obtain the enthalpy?
Table then.
Yeah. Table, right? Okay, so table tu pada saya is detailed explanation. Contoh soalan yang selepas ni 16 markah. But for this you just write the enthalpy, how you get the enthalpy is actually from heat of vaporization. Macam tu je, heat of vaporization. If you want to put table B1, you put kalau katalah you nak letak table B1 referring to the heat of vaporization. You can't just say table B1, okay? Because table B1 there are many information there. So which one is actually enthalpy for that phase change? So you kata this is actually heat of vaporization. So the third step is temperature again kan, temperature, but this one is now okay. Point pertama temperature change from 100 to 400. Second one, data enthalpy-nya adalah CP. This one as I mentioned, CP water gas or water vapor DT. Okay, so from 100 to 400. Okay, so the last step, pressure change. You kata lah, first point you kata pressure change from 1 bar to 3 bar. And then what is the enthalpy? VCAP delta P. Macam tu je. For this 10 marks lah. Saya rasa for this 10 marks itulah dia punya ni. Okay, because and then if you want to add more to that, if you want to add more on, because saya pun tak sure whether this is the correct answer for this. Use the particle process path to express the energy balance equation tu. Saya pun tak sure, tapi saya rasa itulah normally referring to the previous example or previous final exam tu, normally this is the answer lah required. So and then you may add, katalah you nak add because you nak relate the energy balance kan, to relate with the energy balance, you write lah energy balance, this is what open system. So open system, you write Q dot minus W dot S. Ini. Alright, so then you cancel lah. You cancel that negligible parameter, and then you kata Q equal to delta H. So this delta H is actually what? M H out minus H in. So kalau you nak kata lagi H out ni apa tadi? H out ni adalah this one. H out ni is actually summation of CPDT plus heat of vaporization plus CPDT plus VCAP delta P. Boleh jugalah kalau you nak add that one, tapi saya rasa untuk 10 marks tu I guess enough with the one yang kita discuss tu dah. Okay, kalau katalah you nak, kalau kata you nak buat juga, so Q nya M, so H nya will be CPDT from 25 to 100 plus heat of vaporization plus CPDT, ni water, liquid, ni CP water, gas, DT 100 to 400 plus VCAP delta P, okay, minus inlet kita adalah M, because M will be the same M CP water liquid, wait, not responding, DT. So this one is what, 25 to 50. If you want to do this, it would be better, I guess. Okay, because this actually we can see this energy balance. Because kalau enthalpy tu kita nampak macam not that to the energy balance yet lah. Okay. So any questions?
Doctor?
Yes, maybe.
I'm confused about the hypothetical process on outlet. Why do the initial use reference state at 25 degrees Celsius and 1 bar? Why not use 50 degrees Celsius at 1 bar?
Okay, maybe. As I mentioned, this is actually for us as lecturer, when we want to mark, if we give you some reference or a specific reference, the answer won't, we only can have one pattern of answer. Okay, it's not wrong maybe to choose, if you want to do the calculation, it's not wrong to choose liquid 50 degrees C. It's just that to simplify that, to make sure that all students actually follow the same pattern of answering. Itu sahaja. It's not wrong or right. It's also right to choose that.
Okay, doctor.
All right, maybe. Any other questions? If let's say the reference state is not given, so you can choose your inlet as your reference state, or you can also choose your outlet as your reference state. Okay, it's just that when you choose your outlet, if you are about to calculate, then it will be negative value lah, because you are reducing from vapor to liquid kan. So you are releasing the Q. Okay. So if no question, then we proceed to this one. All right. So this one, this adiabatic heat exchanger. Remember, adiabatic exchanger. For this case, it's actually for perfectly insulated lah. Perfectly insulated. It's not that the inlet outlet temperature, no, it's not that the temperature of system and surrounding is the same. This is on more on the perfectly insulated. So that's why the enthalpy or the Q only circulated within the system, not being released. Okay, so for this one, 16 marks. So the answer is quite the same as the previous question. It's just that you need to add another elaboration lah. Okay, so I show you how you give the explanation, because as mentioned here, show and explain. Show and explain. I do not know why this question earlier ni, this question yang dia kata draw ni, draw. So I guess kalau draw, just draw the path without explaining about the temperature change or that. But then later you are asked to use the hypothetical process path. So I think it's the one we discuss here lah. Okay, so for this one, you are required to draw and label completely the above process. and then you are required to simplify the energy balance and then show and explain the hypothetical process path. So if you are about to draw, this is very simple drawing lah. Okay, counter current. Okay, basically, so this is superheated steam, 300 degree C. Remember, it should be temperature and pressure. You should write it this for energy balance. And then the outlet will be saturated liquid, the same pressure, so 5 bar. It's only the same pressure, not the same temperature. 5 bar, and then another stream you have N-heptane. The flow is 100 kilogram per hour of N-heptane. The temperature is 30 degrees C, 1 atm, and coming out as gas N-heptane, gas 120 degrees C, 2 atm. Okay. So this one again C1, C2 because there is no calculation also here. All right. So are you able to get the drawing?
Yes.
All right. Okay. Okay. Because this is very simple drawing, Okay. As I mentioned, if it is 16 marks drawing, this drawing may be 2 marks only. So the other 14 marks is in the explanation. Okay. So write and simplify the energy balance. I'm sure all of you will write this one kan? Okay, this one delta H dot K dot plus delta EP dot. So you cancel. Am I right?
Yes, yes.
So cancel tu, do you give any explanation
Oh,
in the assumption? Okay, your assumption. So you should whether it's assumption ke whatever you want to mention, you have to mention that it must be delta EK equal to 0 because no accelerating. There must be an explanation on that. The previous question we just can omit. If I can refer back, this one. Ni here, you see here, saya potong je without any explanation. That's okay for 10 marks question because the focus is on other thing. But for 16 marks, you have to mention that. Okay, you have to mention delta EK is 0 because no accelerating. Delta EP is 0 also because no rising falling. And then last, work is 0 because no moving parts or no electrical current. So you have to mention that. I think this one, if not half for each explanation, it may be 1 mark for each. So if you just cancel without the explanation, then you lost the 3 marks lah. Okay, all right. Again, this one also I do not have the answer scheme. I think this is not during my time of teaching. Maybe. Okay. All right. So next is on the hypothetical process path of N-heptane. So again, this one actually repeating yang water tadi. So kalau N-heptane inlet, how many path do you get? How many path?
1, Doctor.
1, yes, Nidia. Because your reference state is N-heptane liquid, 25 degree C, 1 atm. And then your inlet for the N-heptane is liquid, 30 degree C, 1 atm. So it's only temperature change. Okay, only 1. Now the explanation, because you have to detail out the explanation and then you have to give more compared to the previous question. So for this first one to N-heptane, liquid 25 degree C, 1 atm. N-heptane, liquid 30 degree C. This is for inlet. Alright, so you should mention here this step is temperature change from 25 to 30 degrees C. Next, your enthalpy is CPDT. CP and heptane, heptane liquid. And then where can you refer the CP? The additionnya adalah where can you refer the CP of N-heptane? Where can you get the value of the N-heptane?
Table.
Table B2. Please have a look, table B2, no N-heptane, no N-heptane. Don't just simply put, You refer to that table. I just noticed also actually during the my discussion with the student, rupanya tak ada. N-heptane is not there in table B2. Okay, so where to get the CP of this N-heptane? Outsource from other handbook. Macam tu ke? The third point tu, you need to explain on the third point ni. How to explain the third point? Outsource from other handbook. Is that so?
Yes, I guess. Using
Yes,
another handbook.
yeah. Okay. Ni dia mention, okay, outsource from other handbook. The rest, how about the rest? Any other answer? No idea.
No idea, Doctor.
No idea maybe. Okay.
Kopsrul ke?
Yes?
Pakai kopsrul.
Yes, Azhar. Kopsrul. That's the correct answer. Kopsrul. Remember Kopsrul? Kopsrul. This is for what? Liquid and solid. So if it's not there in table B2, then you use Kopsrul. So the third point you mentioned, the CP of N-heptane liquid is obtained using Kopp's rule. Kopp's rule. Okay. No need to do any calculation. Just say that it is actually can be obtained using Kopp's rule. Or you can also mention about table B10 because the Kopp's rule is actually taken or obtained from table B10 with a simple calculation kan. So you can mention about Kopp's rule ataupun obtained from table B10. Okay, so the third point. Because this is 16 marks, so you can see the difference between the previous question tu. Previous question yang third point ni kita no need to explain lah. Alright, so now for your, itu settle for the heptane inlet. How about heptane outlet? How many paths are you getting? Heptane outlet?
I'm sorry, Doctor. I want to ask about the COPS rule. In the previous slide, in the previous PPT, the last one, it said that COPS rule can be used when estimating CP of solid or liquid at 20 degrees Celsius based on.
Yeah. It's
Can
actually
we-
20 degrees C. So this one to make it to add your elaboration, but I did also mention, right, although it's at 20 degrees C, but still it is estimation. So you actually can use it at temperature not at 20 degrees C because estimation. So I think we should mention anywhere the CP of an ethane liquid can be obtained, is estimated because estimation, because the temperature is not at that 20 degrees C. Our temperature here is 30 degrees C, right? But you still can use that because it's estimation. Okay.
Okay, thank you, Doctor.
Okay, thank you, Nidia, for highlighting that. So for outlet, how many paths do you get? For N-heptane outlet. 4. Yes, 4, Zulfahmi. 4, the first step, temperature, the second step, phase, the third step, temperature, the last step, pressure, right?
Yes.
Okay. So for this one, so each step too, you need to explain lah. Okay. Each step you need to explain. Wait. If I can add another slide. Okay. So as I mentioned earlier, the elaboration is that but before that, I think I would like to answer to Nidia previously about the 20 degree C. 20 degree C, actually you can use at any temperature. Okay, at any temperature. So, it's just that macam we can neglect the 20 degree C. Wait, let me check the Cox rule. Where is the Cox rule at the end? Sorry. Saya tengok chapter 7 padahal chapter 8.